Have you ever wondered how databases maintain their performance, consistency, and reliability in the face of network failures? Let's embark on an enlightening journey into the world of computer science, where we'll unravel the mystery of the CAP theorem. In the realm of distributed systems, CAP theorem is a fundamental principle. Coined by computer scientist Brewer, CAP is an acronym that stands for consistency, availability, and partition tolerance. Each letter represents a critical aspect that determines how a system behaves and responds to network failures. Consistency ensures that all nodes see the same data at the same time. Availability guarantees that a system continues to function even when part of the system goes down. Partition tolerance implies the system's resilience to network failures. However, the CAP theorem asserts a hard truth. It's impossible for a distributed data store to simultaneously provide more than two of these three guarantees. Intriguing, isn't it? But what do these terms mean, and why can't we have all three? Let's break down these three elements. Consistency means every read receives the most recent write or an error. Availability means every request receives a response, without guarantee that it contains the most recent write. And partition tolerance means the system continues to operate despite arbitrary network failures. Imagine you've just updated your status on your favorite social media platform. You expect all your friends to see the same status update, right? That's consistency for you. The system ensures that everyone sees the same data, the most recent write, or they see an error. Now think about using an ATM. You expect it to give you cash anytime you need it, irrespective of whether it's able to connect to the bank's main server or not. That's availability. Every request to the ATM gets a response, even if it may not contain the most recent balance information. And then there's partition tolerance. Picture yourself driving through a tunnel using your GPS. Even if you lose signal temporarily, you expect the GPS to continue working, right? That's partition tolerance. Despite network failures or partitions, the system continues to operate. However, there's a catch. The CAP theorem states that a distributed system can only guarantee two out of these three properties at the same time. It's like a game of rock, paper, scissors. You can't have all three. You have to make a trade-off. Do you prioritize consistency and availability but risk network failures? Or do you ensure availability and partition tolerance but risk showing outdated data? In reality, the choice between consistency, availability, and partition tolerance depends on your system's specific needs. If you're running a banking system, you might prioritize consistency and partition tolerance. But if you're running a social media platform, you might prioritize availability and partition tolerance. So, in essence, the CAP theorem is all about choosing the right balance based on your system's requirements. It's not about winning all, but about making the right choice.